Record and let's do this. Okay, today we will be graphing the sine and cosine functions. And we'll be doing it by transformations, and we will be doing it by key points. So it'll be up to you to determine which method you like best. That's why I show both methods, but transformations is just so much better. Okay, when we get there. For now, we're graphing the sine function, and the properties of sine is that the domain's all real numbers. The range of the sine function goes from -1 to 1. Sine is an odd function. We learned that last time. And sine is periodic. It has a period of 2 pi. It repeats itself every 2 pi. We learned that last time. The sine function will have x-intercepts at multiples of pi, and it has a y-intercept at 0. Okay, now when you're graphing the sine function, you want to be smart about the coordinates you pick because you want to graph easy coordinates. So that's why I copy and pasted the unit circle here. Okay, looking at our unit circle, if we wanted to graph the sine function, what would be the easiest coordinates to graph looking at this unit circle? I mean, 1/2's not bad.
1, 0.
Good. 1, 0, 0, 1, -1, 0, and 0, -1. Graphing 1/2 isn't bad, but do you want to graph the square root of 2 over 2?
We
Pass.
don't, but I mean, I feel like you might.
Do you want to graph the square root of 3 over 2?
Hard pass.
Hard pass. There you go. So 1 and -1, these coordinates are the best ones to choose. So when you pick your x values for the sine function, here's what we're going to do. We're going to start with the negatives, and I'm going to start with -2 pi. And then I'm doing negative angles, then I'll come into the positive angles. So -2 pi, -3 pi over 2, -pi, -pi over 2, and then 0, pi over 2, pi, 3 pi over 2, and 2 pi. These are the perfect coordinates to pick for the sine function, because the sine at 2 pi, at -2 pi, is going to be 0. The sine at -3 pi over 2, so when I say that, the sine of -3 pi over 2, remember that sine is odd, so we can rewrite it as the negative sine of 3 pi over 2, which means you'll get -1 times -1, which means the sine at -3 pi over 2 is a positive 1. And then the sine at pi will be 0. Sine at -pi over 2 will be -1. Sine at 0 is 0, 1, 0, -1, 0. If you're wondering where I'm getting these values from, it's from the unit circle there on your right side. So these are going to be considered the parent function coordinates for the sine function, and will be very useful when you are using transformations. Okay, so any questions on that XY chart? Okay, so now let's just go ahead and graph our sine function. So I'm going to label my x-axis, and I'm going to make this -2 pi, -3 pi over 2, -pi, -pi over 2, and 0. And then pi over 2, pi, 3 pi over 2, and 2 pi. And then the highest we go is 1, and the lowest we go is -1. Now let's go ahead and plot the points from the above. There we go. So at -2 pi, we're at 0. I can make that bigger. Sure. There we go. -3 pi over 2, we are at 1, and then 0, and then -1, 0, 1, 0, -1, 0. So my sine function looks like this. Hang on. There we go. Showing that it repeats its cycle every 2 pi. If you took this graph and copied it over there, it'd be the same exact thing. And then also showing that the range goes from -1 to 1. So the sine function goes up to 1, down to -1, up to 1, down to -1, infinitely, from -infinity to infinity. Sine is an odd function. Remember, if you're odd, you reflect across the origin. That means that if this point is pi over 2 and 1, that means at this point, if you reflect it across the origin, is -pi over 2 and -1. And you see you have intercepts at multiples of pi. So there's an x-intercept, intercept. Those are all multiples of pi. And you have your y-intercept at 0. That is the graph of the sine function. Any questions on that?
Is that graph what you would call a sine wave?
Yeah. For sure. Okay. Everybody good with this? All right. Which means let's go ahead and get into transformations then. All right. So if we are given a trig function in the form of y equals a times the sine of omega x, well, omega is going to be your transformation. And a and omega will be your transformations. So if you guys remember transformations from college algebra, here we're given y equals 3 times the sine of x. What does the 3 do? Does it transform your x coordinates or your y coordinates?
Y coordinates?
Good, y coordinates. Because it's on the outside of the function, right? So anything that multiplies a function will affect your y values. So this means that 3 is going to be considered a vertical stretch. So that 3 in front is a vertical stretch. Maybe I could zoom in and write that. This is a vertical stretch. Okay, and since we're using transformations, I went ahead and did you a favor and put the parent function's coordinates here already. Since this is just a transformation on your y values, our x values are going to stay exactly the same. So I'm still going to have -pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And all I have to do for this transformation is multiply all my y values by 3. All the parent function y values by 3. So that'll just be 0, -3, 0, 3, 0, -3, and 0. And look how fast the transformations are. And all we have to do is plot this. So here's -pi, -pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now the highest we go is 3. The lowest we go is -3. Okay. And of course, I could finish the rest of these values off because that'd be -2 pi and -3 pi over 2. Okay. So -pi, we're at 0. -pi over 2, we're at -3, 0, 3, 0, -3, and 0, which means since it's odd, you'd figure that at -3 pi over 2, we'd be at 3 and then 0. So here's what my transform sine function looks like. All we did was take the y values and stretch them by a multiple of 3. That's it. Any questions on that? Remember transformations? See how algebra is involved in everything? All right, everybody good?
Yep.
All right, one yup, that'll work.
Yep.
Let's keep going. Okay, so that was the sine function. Now we get into the cosine function. And the properties of cosine, it's almost the same as sine. The domain's all real numbers. The range is -1 to 1. Cosine is even and also repeats itself every 2 pi. But this time the x-intercepts are going to be at odd multiples of pi over 2, and the y-intercept is 1. All right, and like I said, just like sine, you are going to want to pick the same radian values for cosine. 0, pi over 2, pi, 3 pi over 2, and 2 pi, because these are the nicest numbers to graph. Okay, so this means that for my XY chart, we again will have -2 pi, -3 pi over 2, -pi, -pi over 2 and 0, and then pi over 2, pi, 3 pi over 2, and 2 pi. All right, now cosine at -2 pi. Remember, cosine is even. So that means cosine of -2 pi is the same as cosine of 2 pi. And what is the value of cosine at 2 pi?
One.
1. Good. What would the cosine at -3 pi over 2 be?
Zero.
0. What about the cosine at pi, negative pi?
One or -1.
Which one is it?
Let's say 1.
Ooh. If it's the cosine of negative pi, remember it can be rewritten as the cosine at pi. So what is cosine at pi?
-1.
-1. And then cosine at pi over 2?
0.
0. Cosine at 0?
1.
1. And then what are the rest of the numbers? Oh, follow the pattern from above.
0.
0. What else?
-1.
-1. What else?
0, 1.
0. 1.
Can you kind of clarify again, like we said, because sine's odd and cosine's even on this? Because
What is it? What does it mean to be odd?
Unusual.
Yes, all math majors are unusual. But graphically, what does it mean to be odd? We talked about it last time. No Nobody listens to me. If you're odd, you reflect across the what?
X-axis?
That was Y.
Keep guessing.
Origin?
Origin. That's why I drew those coordinates there, because they reflect across the origin. That's what it means to be odd. And algebraically, that's why I wrote when I said the sine of negative 3 pi over 2, since sine is odd, it's also the same as the negative sine of 3 pi over 2. And that's why we got +1 for that coordinate. Did I clarify it?
Yeah.
You sure?
I think it'll make more sense when we keep going.
Now, since cosine's even, that's why the cosine of any negative angle can be rewritten as the cosine of a positive angle. That's why I said the cosine of negative pi is the same as the cosine of pi. And this is only true because cosine is even. It has nothing to do with picking the coordinates. The reason we pick the same coordinates as sine is because 1 and -1 are easy to graph. We don't want to graph the square root of 3 over 2. We don't want to graph the square root of 2 over 2. And we definitely don't want to graph 1/2. So that's why we pick these radian values.
So kind of like if it's sine, if it's odd, it's gonna change the sign on the inside, and it's gonna move to the negative or positive is gonna move to the outside.
Exactly.
Where even, it's just gonna change inside the parentheses.
Exactly. Then label this. Highest we go is 1. Lowest we go is -1. All right. And plot. Negative pi over 2 and 1, and then 0, and then -1, 0, 1, 0, -1, 0, 1. And here we go. And this is the graph of cosine. And remember, since cosine's even, it reflects across the y-axis. And cosine repeats itself every 2 pi. So since it's symmetric, that means I can take this point of pi over 2 and 0 and reflect it over the y-axis to give me negative pi over 2 and 0. I could do the same for these points as well. And by the definition above, we see that the x-intercepts happen at odd multiples of pi over 2, and you have a y-intercept at 1. So this is what the graph of cosine looks like. Any questions on that? All right, then. Let's do another transformation. So here we're given y equals 2 times the cosine of 3x. What type of transformation does that 2 do?
Stretch, whatever it's called.
That's a vertical stretch. Okay. What type of transformation does the 3 inside do?
Horizontal compression.
Good. Horizontal compression.
Why is it a horizontal instead of a vertical compression?
You tell me, Ethan. Don't you remember college algebra?
Not to that fine detail.
Because it's not a negative.
Nope. So remember, vertical transformations happen on the outside of a function. Horizontal transformations happen on the inside of a function. They happen with the argument of a function. And the reason this is a horizontal compression is because the number inside is greater than 1. So with horizontal compressions or stretches, the easiest way to figure out what to multiply by is you always multiply by the reciprocal of whatever number's in there. So that's why if there's a 3x in there, it's a compression, because when we do our transformations, we're going to multiply all our x values by 1/3, the reciprocal. So horizontal compressions, you always think opposite. That's why if we had, let's say it was cosine of x minus 3, what type of transformation would that be?
+3.
That could be a shift to the right.
It would be a horizontal shift to the right plus 3 units, right? So again, you always think opposite. So what if it was cosine of 1/2 x? What would you multiply all your x values by?
It's gonna by 2, so that's gonna be a horizontal stretch then.
That would be a stretch. Good.
So horizontals are always inside.
Opposite and inside.
Verticals or
Outside.
okay.
So I guess we could say, let's say we had a combo. Let's say we had 2 cosine of 2 times x minus 3 plus 1. Tell me all the transformations that are going on this one.
I give up.
The 2 would be a what?
Vertical stretch.
Good. The 1 would be
Like
shift
a
up.
Shift.
good. It would be a vertical shift up, right? So you would stretch and shift. The 2 would be a what?
Horizontal compression.
By what? By what
1/2.
factor? 1/2. And then the x minus 3 would be?
Shift to the right, 3.
There you go. See? You remember. That's it. That's it, guys. So now, since we're using transformations, I have the parent function's coordinates, which means we can now transform them. So here are the parent function coordinates, some of the parent function coordinates for cosine. We don't need all of them. And now we're going to do the horizontal compression by multiplying all the x values here by 1/3. So you get negative pi over 3, negative pi over 6, 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. So we multiplied all of these by 1/3. If you need to put that 1/3 in front to see, then go ahead and do it. Okay. And then, since it's only a vertical stretch by 2, you take all these y values and multiply them by 2. Negative 2, 0, 2, 0, negative 2, 0, 2. There you go. And of course, you can always check your work, which would be wise to do. let's go ahead and pick, let's try this first coordinate. Actually, no, we'll make it easier. Let's try 0, 2. So let's go ahead and check this work. We're going to get y equals 2 times the cosine of 3 times 0. This will give me 2 times the cosine of 0. What is the value of cosine at 0?
0.
Remember, cosine relates to x. One. And therefore, we'd get 2, which means that when I plug in 0, I get an output of 2. Does that match the coordinate I circled above?
Yeah.
There you go. So always check your work. And know your unit circle. All right. Let's go ahead and plot. So now this is going to be negative pi over 3, negative pi over 6, 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And this will be negative 2 pi over 3 and negative pi over 2. The highest we go is 2, and the lowest we go is negative 2. Okay. Now plot negative pi over 3, we are at negative 2. And then negative pi over 6, we are at 0, 0, 2, 0, negative 2, 0, and 2. And then just reflect these across. At negative pi over 2, we'd be at 0 and then 2. So here's what my transformed cosine function looks like. What we did was horizontally compress it and then stretched it by 2. If I were to draw the original cosine function for this graph, we would look like this. You would have, actually probably be a little flatter. Let me see. That's what the original cosine function would look like on this horizontally compressed graph. Crazy, right? Maybe it's just easier to go back. There we go. Bam. Okay. So those are transformations. Any questions on those?
No.
Okay. All right. Next, let's go ahead and get into the amplitude and the period, finding the period of these given sinusoidal functions. So if b is greater than 0, the amplitude and period, oh, not b, I should have changed that. That should be omega, sorry. Let me write that in. Oop. B, ha. This should be omega. There we go. If omega is greater than 0, the amplitude and period of y equals a sine omega x and y equals a cosine omega x are given by the amplitude is equal to the absolute value of a, and the period is given by t equals 2 pi over the absolute value of omega. Okay. So all we want to do in these exercises is find out what the amplitude and period is of each of these given trig functions. So for number 1, we're given y equals 3 times the sine of 4x. So what is the amplitude of this function?
3.
3. So here, my amplitude is 3. The amplitude tells you how high your function goes and how low your function goes. So if we were to graph this function, we would go up 3, down 3, up 3, down 3. Okay. And now to find the period, since there's a transformation inside, the period changes. To find that, we put 2 pi over the absolute value of 4, which is just 2 pi over 4. So the period of this transformed trig function would be pi over 2. So what this means is that since there's a transformation, the period of this function is no longer 2 pi. The period of this function will repeat itself now every pi over 2 units.
Yeah, so okay, so that 2 pi is over any number that would be inside the.
Inside the argument of the
Gotcha.
trig function. And we see how it changes their cycle. We graphed the last transformation of cosine and we saw that we compressed it by a factor of 1/3. That means you changed up its actual period. Okay, do it again. Y equals 6 sine of pi x. What is the amplitude of this function?
6.
6, good. And then the period is going to be 2 pi over the absolute value of pi.
Should be 2.
That's it, just 2. So this means that this function would repeat itself every 2 units. All right. 3. Find the amplitude and period. We have 9/5 cosine negative 3 pi over 2x. All right, what is my amplitude?
5ths.
9/5. What is my period? 2 pi over the absolute value of negative 3 pi over 2. Which becomes 2 pi over positive 3 pi over 2, which means you'll multiply by the what?
Reciprocal, so it'd be like 4/3.
Good, because your pi's will cancel, right?
Yeah.
4/3. All right, perfect. That means this would repeat itself every 4/3. All right, that is amplitude and period, which is going to help us for the next page. Because if you absolutely hate transformations, then there is another way to graph these trig functions, and you can do it by key points. So let's get into that. So here we want to graph y equals 3 times the sine of 4x using key points. So before we get started using key points, we need to know what the amplitude and the period of this function is. So for 3 sine 4x, what's my amplitude?
3.
3. And then my period is going to be 2 pi over 4, or just pi over 2. Okay. So this is how key points works. We take the period of this function and we divide it into 4 sub-intervals. So the first thing we need to know is the length of each sub-interval. So the way to do that, since we're dividing it into 4, we're going to say that the length of each interval. And this formula is going to be given by the period over 4. So this means that we take the period from above and divide it by 4. Why 4 subintervals? Because it's just easier that way. You can create 2 subintervals, 6 subintervals, 10 subintervals, but the homework will only ask you to create 4 subintervals. So in order to do so, we need to know the length of each subinterval. So we take the period, we divide it by 4. Pi over 2 divided by 4 gives me what?
Pi over 8.
Pi over 8. So this is the length of each subinterval. So now we start creating our subintervals, and we always start at 0, and we'll add the length of each subinterval. So this means that number 1, for our first interval, we're going to start at 0, and we're going to add the length of our intervals. So what is 0 plus pi over 8?
Pi over 8.
Pi over 8. There's your first subinterval. Your second subinterval will start where you left off. You're going to start at pi over 8, and you'll add another pi over 8. So what's pi over 8 plus pi over 8?
2 pi over 8.
Which reduces to
Pi over 4.
pi over 4. And then we'll do it again. Your third subinterval. You start at pi over 4, and you add another pi over 8. So cheat code this. Remember that pi over 4 was 2 pi over 8. So we'll just start here again. Add another pi over 8, and what are you going to get?
3 pi over 8.
3 pi over 8. Which means we're on our fourth and final subinterval. 3 pi over 8 is where we start, and you add another pi over 8. And that'll give you 4 pi over 8. But what does that reduce to?
Pi over 2.
Pi over 2. These are the 4 subintervals that we are going to use to help us graph this trig function. And all of these are x values. These are all x values. Okay. And to show that you got your intervals correct, the last part of your fourth subinterval should match the actual period of your trig function. This is pi over 2, and that is pi over 2. If those match up, you're good. If those don't match up, you must check your work. Okay. And now the fun part. We need to find y values because all we have found now are x values. So we're going to take all of these x values and plug them into the original function to give us a y value, because that's how coordinates work. You plug in an x, you get a y. So we're going to be plugging all of these in to 3 times the sine of 4x. So let's start plugging away. So you're going to have x equals 0, x equals pi over 8, x equals pi over 4, and then x equals 3 pi over 8, and x equals pi over 2. Okay. So we're plugging these into that function. So this means you would have y equals the sine, forgot 3. Y equals 3 times the sine of 4 times 0. Y equals 3 times the sine of 4 times pi over 8. Y equals 3 times the sine of 4 times pi over 4. And y equals 3 times the sine of 4 times 3 pi over 8. And y equals 3 times the sine of 4 times pi over 2. Who's liking transformations more?
Yeah, the other way's a lot better.
I'll go with they both suck.
Of course.
Agreed.
Of course. Okay, but of course, I'm going to show you how to make your life a little bit easier on these using Desmos, of course. If I had the other calculator programs, I would show it. But if you want to see those, watch the old videos that I have recorded. I think I'll get that. I'll get the TI-84 back in my calculator, hopefully in the next 2 weeks. The department's going to buy them. For now, we deal with the free program that we know as Desmos. Okay, first off, make sure your calculator's in radians because we're only plugging in radian angles. And I'm going to type in our function. Y equals 3 times the sine of 4x. And then I'm going to use that table feature. Click that little gear icon above and click the table. And let's go ahead and type all these values in. So this means that 0 pi over 8 pi over 4 3 pi over 8 and pi over 2. Look how nice that was. And over here, I'll fill these out. So at 0, you get 0, 3, 0. -3 and 0. Boom. Desmos for the win. And now you have your 5 coordinates that you can plot on this graph. What's up?
You said on your old videos, you have it how to use the with the TI-84.
I think I show the TI-84 and this little blue calculator. But I can tell you how to do it real fast once I graph this. I got those instructions memorized in my head. So here's 0 pi over 8 pi over 4 3 pi over 8 and pi over 2. Ugh, so ugly. There we go. Pi over 4. And you can also repeat them. Why not? Negative pi over 2, negative 3 pi over 8, negative pi over 4, and negative pi over 8. Highest we go is 3. Lowest we go is -3. And graph. So 3 we're at, or 0 we're at 0. Pi over 8 we're at 3, 0, -3, 0. Reflect across the origin since it's sine, and I'll get a point here, 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 and there. And there you go. It's definitely a lot more work, but maybe there's some pros to this. You don't have to remember the parent function's coordinates, and you don't have to remember a thing about transformations. All right. You're using the TI-84?
Yeah.
All right, TI-84 instructions. I can't even spell. TI-84, okay. First thing you're gonna do is make sure you're in radians. Are you in radians?
Now I am.
Okay, now you're gonna hit your Y equals button
Mm-hmm.
and type in the function.
Okay, yeah, I typed in the 3 sine
3 sine 4x. Okay, now you're gonna hit second and window, which should be right next to your Y equals button.
Oh, yeah.
So you hit second window, and then you should get some things like, what does it say?
It says table setup, table start 90.
Table start, table, does it say like change table? The little triangle.
There is a little triangle and it says table equals 1.
Okay, so, well, first of all, we're just gonna ignore all those, and you're gonna keep going down until you see, what does it say?
It says independent.
Good.
Independent.
So independent, it should say auto and ask, right?
Yeah.
So go ahead and highlight ask.
Okay.
After you do that, just hit second again and hit your graph button.
Oh, okay. And then that's where you can type in.
It should pull up an XY chart. And if there's numbers there, just go ahead and delete. But if there's nothing there, then just go ahead and start typing in. And you can type them in just as I did, 0, pi over 8. It's going to change pi over 8 to a decimal number, though. But it's fine, because all we're worried about is the Y values. And you should get the same Y values that we're getting.
Yeah.
You getting the same values?
Yep. So far, yeah.
All right, there you go. See, and that's how you use your calculator.
Cool.
So, when you were describing the pros and cons of this transformations, what did you mean on transformations of remembering the parent function?
Remember when we did these ones, you have to know the parent function's coordinates in order to transform it. Which isn't hard because all you're looking at is the cosine of 0, pi over 2, pi, and 2 pi. So I'm not saying remember all of these. If you just remember one cycle, 0 to 2 pi, you're going to be just fine.
Okay.
So if you remember 0 to 2 pi, that's all you need to know for your parent function coordinates. But key points doesn't care about any of that. So you choose which one you like. Don't switch back and forth because then you're going to confuse yourself. So either stick with transformations or stick with key points. For the rest of this lesson, I'm doing transformations. It's just so much faster. Okay. So let's go ahead and practice graphing these. What do we have? Just these two left. Perfect. Okay. So like I said, I'm doing it by transformations. I mean, I do have all the time in the world to show key points if anybody wants me to, but let's go ahead and do this by transformations. So when I say transformations, what does this negative do in front? Oh boy.
Reflects it across the y-axis?
It's on the outside of the function. So remember, it's going to reflect it over the x-axis because it affects your y values. All right. And what does the 4 do?
Vertical stretch.
Vertical stretch. Good. What is the pi going to do?
Horizontally compress it.
Horizontally compress it. Because pi is bigger than 1, right?
So if it was pi over 2, would that still be a compression? Because pi is like 3.14 over 2.
Yep, it'd still be a compression. So just to keep it simple again, just multiply by the reciprocal. And what's this minus 2 going to be? A what?
Shift down.
Vertical shift down. Look at that. So now we're ready. We're transforming cosine. So here I'll make my parent function chart. And like I said, I just need that one cycle. So here's x and the cosine of x. And I'm just going to go from 0, pi over 2, pi, and 2 pi. And we know that this is 1, 0, negative 1, 0. And now I will transform. And for my transformation XY chart, well, let's look at what we're doing to the X values. We are only horizontally compressing the X values. So that means I'm going to multiply all of them by 1 over pi. But then for my Y values, we are reflecting them, we are stretching them, and we are shifting them. So we have to think of order of operations. The first thing we're going to do is take all our Y values and multiply them by -4. And then after you multiply them by -4, you're going to subtract what from them?
2.
2. There you go. Let's do it. Well, 1 over pi times 0 is 0. And then -4 times 1 is -4. -4 minus 2 gives me -6. And then pi over 2 times 1 over pi, your pi's will cancel and give me 1/2. -4 times 0, 0. 0 minus 2 gives me -2. And then pi times 1 over pi, your pi's cancel and leave me with 1. Plug in -1. -4 times -1 is 4. 4 minus 2 is 2. And then 2 pi times 1 over pi, your pi's cancel. I get 2. And then plug in 0, you get -2. Yeehaw. All right. Now plug in 2. I get 2 pi, which is 1, -4. Oh, no. Whoops. Did I mix that up? Oh, I missed the coordinate. That's why that didn't make sense. My bad. See, I messed up my parent function. Hang on. I skipped one. That should be pi, 0, pi over 2 pi, 3 pi over 2, and 2 pi. Now that makes sense. That'd be 0. That'd be 1. And now we can continue. So that goes there. That goes there. That goes there. And then 3 pi over 2 times 1 over pi, your pi's cancel. And you get 3/2. And 0, plug in 0, you get -2. That's much better. And then you plug in that, you get 2. And then you have 1. -4 times 1 is -4 minus 2. You get -6. Much better. And that's why we don't do turbo math. And by transformations, that is now done. So you have 0, 1/2, 1, 3/2, and 2. And the highest we go is 2. And I think we have to do this by multiples of 2. So this will be 2, 4, 6. And then down here, -2, -4, -6. And then -1/2, -1, -3/2, and -2. Plot my points from above. And and 0, -6 there. 1/2 and -2. 1 and 2. 3/2 and -2. And 2 and -6. So once again, cosine's even. So all you have to do is reflect it across the y-axis. And at -1, you'll get 2. -1/2, you'll have -2. 3/2, you'd be at -2. And -2, you'd still be at -6. So this is what we look like. So we took the original cosine function, we flipped it over the x-axis, we stretched it by 4, shifted it down 2, and then compressed it by 1/pi. Anybody want to see that done with transformation, with key points?
Key points is pretty simple. It's just time consuming, but it's not like,
Yeah.
I don't think it's hard to understand.
All right then. Let's move on. All right, last one. All right. What do we have? Oh, find an equation for a sinusoidal graph. So, given the graph, let's go ahead and find the equation that it most relates to. So first thing they're giving us is the period. So they're saying that the period is equal to 1. So the period of this trig function will repeat itself every 1 units. Okay. So thinking about the trig functions we graphed today, does this look like a sine or a cosine?
I don't remember what they look like. I'm just gonna say sine.
Look at your notes. Unless you're just following along. So remember, sine always runs through the origin at 0, 0. Cosine always runs through a y-intercept above 0 or below 0. So if you look at this graph at 0, what is it doing?
It's going through 3.
It's going through a y-intercept of 3. So this graph would relate most to which function?
Sine.
Oh, sine.
Cosine. This would relate to cosine. Okay. Well, there's some things we need to figure out. Now we know that this graph relates to cosine. So this means we need to find omega and we need to find A. Well, A is easy. A is the amplitude. What is the amplitude of this graph shown?
So 3?
3. It goes up 3. It goes down 3. So we have y equals 3 cosine omega x. Okay. Now,
So 3.
what? What's up?
So amplitude on a, like, not an equation, but in a graph, it's just the value that goes, like, basically the 0 to the highest point or 0 to the lowest point.
Yeah. How high the graph goes, how low the graph goes. Okay. So they're giving us the period here, which can help us solve for omega. So if you go back to the page in the notes, what is the formula to find a period of the trig function?
Absolute of A.
That is finding amplitude. What is the formula to find the period?
Is it A comma B?
Formula. How do you find the
Double
period?
With the
2
2
pi
pi
over absolute A.
We're getting there. 2 pi over the absolute value of omega.
Oh, omega, yeah.
So if they're giving us that the period is 1, then you take 2 pi over omega and set it equal to what number?
1.
1. And solve for omega. Which means all you have to do is multiply omega to the what side?
Right.
So you get 2 pi equals omega. And we got it. Y equals 3 cosine 2 pi x. That's it. And of course, that's one out of many equations that could represent this graph. Any questions on this one? All right. Last one. Write the equation of a sine function with the amplitude of 2 and a period of 7. So here we want to write a sine omega x. Well, first part's given. What's the amplitude?
2.
2. 2 sine omega x. All we have left to do is solve for omega. Which means, again, you would take 2 pi over omega and set it equal to what number?
7.
7. And multiply to the right side. And 2 pi would equal 7 times omega, which means omega, if you solve for omega, what is omega going to be equal to?
2 pi over 7.
2 pi over 7. There we go. And we get y equals 2 sine times 2 pi over 7x. There it is, y'all. Okay, that's graphing sine and cosine. So if you like transformations, stick with transformations, but you must know the parent function's coordinates. If you don't like transformations, then you can definitely graph by key points.
Going into like calculus, cal 2 and all that stuff, do you think it's more important to remember transformations or over key points or whatever?
It's important to remember all the stuff. You'll do transformations in calculus. You'll do transformations in cal 2. It's just the simple stuff that everybody forgets. Like in calculus, I'm teaching my students how to factor again. Don't forget that stuff. But it happens. You learn more advanced math, so you forget the little things. So they're doing the advanced techniques and they get stuck. And the reason they're stuck is because they either forgot how to subtract or add something to the left or right, they forgot how to factor, or they forgot how to solve. And it's okay for it to happen like 1 or 2 times, but multiple times, then you definitely need to do a refresher on your algebra. That's why we don't forget the little things, such as transformations. Okay, so that's it. We're finished.